Hello everyone, a very good evening to all of you. Am I audible to all of you? Good evening Mohit. Mohit, am I properly audible? Okay, good. So, in the last class, I told you that in case of steady state non-isothermal reactor design, there is the one more requirement, one more need to get the relationship in between the conversion and temperature. That relation we will get by applying the energy balances over the reactor. Once I will get this balance, I will find out that what is the path of the reaction inside the reactor, and accordingly at different rate I will get the 1 by minus RA. So means for the different conversion I will get as different 1 by minus RA, and from that curve Leven's plot I will calculate the volume. So in this sequence just we learn how to apply the energy balances over PFR. Okay, how we'll apply the energy balances over ideal batch reactor. So all these things I told you in the last class. If you have some doubts in the energy balances over CSTR, so just we discuss the two questions. Okay, anyone who have the doubt in the last class can tell me. If you have the doubt in any point, okay, in the from the last class, so just you can tell me if anyone have the doubt. Anyone, any type of doubt from the last class? Otherwise solve this question. Question came in gate 2007. Question number 83. So try to solve this question. Mohit, am I audible na? Gate 2007, question number 83. All the students will solve this question fast. Energy balance over the ideal batch reactor. So solve it fast, then after that we will discuss further in the steady state non-isothermal reactor design. Pratyusha solved. Okay, good. Other students? Okay, Davis. Other students, you find it? So, all the students saw this question? Okay, no problem. After that, write down the next one heading. Effect of feed temperature. Effect of feed temperature. Put this heading. Effect of feed temperature. Effect of feed temperature. So first we will see for first we will see this thing for irreversible reactions. For irreversible reactions, either reaction that is the exothermic or reaction that is the endothermic reaction. Irreversible reactions, either reaction is exothermic or endothermic. So for irreversible reactions, who will tell me that the curve in XA versus T, XA versus T, how we will draw the curve XA versus T? That thing we will get from the rate. Understand na? What was the minus RA? So I told you del of minus RA divided by del T for the fixed conversion that is greater than 0. Understand or not? So which type of curve we will get? What will be the nature? Because just that will be the little bit different or shift, as the reaction is first order, reaction is second order, reaction is of zero order, reaction is of third order. But tell me all about nature of this curve, how it will be drawn, because this thing we see in the starting class. Who will tell me? Just send me the random picture. Irreversible reaction, XA versus temperature. Good, Devesh. So that will be in this way. Correct. So means, sir, this will be, because this thing we already see na in one of the questions. Okay, this thing we already draw. So minus RA, okay, 1 means, let's say the value is 1, 2 or any value for this rate, because that is the concept of contour. I told you that to draw the 3D curve in the 2 dimension by taking one of the variable as parameter, means across this curve rate is constant. We want to draw in between conversion versus temperature, because rate is what? Rate is the function of K and XA. K, it is the function of temperature. So rate is the function of temperature and conversion. We are drawing conversion versus temperature. So rate, that is the constant along this curve. Understand na? This thing I already told you. So for reversible exothermic or endothermic reaction, the nature of the curve will be something like that. Okay, so minus RA minus RA 2 minus RA3. Then what we will do, sir? We will take that what is the feed temperature. Let's say this is the uh, feed temperature TF. TF is the feed temperature. After that, what will be the path of the reaction inside the reactor? How that will be decided? That what will be the relation in between conversion and temperature? That this thing we will get it as from the reaction, from stoichiometry, from minus RA. That what will be the relation in XA versus temperature? How we will get this thing? That it is the following linear path in this way. Okay, it is following, you can say it as any other path, means that path is in this way, this path. How we will get this thing? Who will tell me that what will be the path? Path means at different temperature what will be the conversion? What will be the conversion, then what is the rate at different conversion? Who will tell me how I will get it as this line or this curve? How I will get this thing? Or which provide this that how the conversion is the function of temperature inside the reactor? Who will give me this information? Good, Pratyusha, that will give by the energy balance. Energy balance. Good, Mohit. So that will give by the energy balance. So if that is remembered to you, what was that in the CSTR? We already see T, temperature at exit, is equals to inlet temperature, plus m into xa, m into xa. That m, that was the slope. Understand? That m was the slope. T naught or Ti naught, that is the feed temperature. Okay. So T naught or Tf or Ti naught, these are the feed temperature. No problem all about that. So now tell me, when the feed temperature will increase or decrease, then what will happen? Who will tell me? Feed temperature. So let's say that is minus Ra4 minus Ra5. So previous case, this was the feed temperature Tf1. Now the same means if I'm getting it as, let's say, from the energy balance, this curve or this curve. So with the same slope that is the same. But if feed temperature that is increased, Tf2, feed temperature is increased, okay, same slope, then what will happen? The same slope, T is equals to T naught plus mxa, okay, that m is fixed. So the temperature at the exit will be increased or not? Will it be or not? So temperature at the exit will be more. So as the feed temperature increases, so that is that curve xa versus t for the fixed rate, for same conversion temperature will be more. Okay, so at the as the feed temperature increases, okay, Tf increases, then tell me all about the rate. Rate will be high or low? You can see, so rate will be high or low means that was the fixed conversion at the exit. This will be the rate, and corresponding to this rate, corresponding to this temperature, what is the rate? Rate is in between minus Ra2 and minus Ra3. Okay, for this conversion, let's say xa1. For this conversion, so conversion increased, temperature increased, and means it becomes the temperature. Let's see, this becomes the temperature. At this temperature, rate is what? Minus Ra3. At this temperature and conversion, what was the rate? Rate was in between minus Ra2 and minus Ra3. This is the rate. Okay, this point, that is the rate. So rate is increased or decreased? So what will be the effect on rate? So as feed temperature increases, so rate increases. Minus Ra increased. Rate of disappearance of A increases for irreversible reactions, either endothermic or exothermic. And what we know in the design equation, you can already see V volume is inversely proportional to the rate. Rate high, the volume for the reactor will be the low. So from that curve, understand or not, I will get this curve, conversion 1 by minus Ra. So at different value of conversion, different rate, different value of conversion, different rate, different value of conversion, different rate. Then, sir, from these data which I am getting from this curve, I will draw 1 by minus Ra versus Xa. You already know why 1 by minus Ra, not only minus Ra. 1 by minus Ra will give us the volume of the reactor. Volume of reactor. Volume of reactor. So temperature increases feed temperature, because we are seeing the effect of feed temperature for the irreversible reaction, either endothermic or exothermic, taking place in the MFR, PFR, or whatever the reactor. So if feed temperature increases, rate increases. Rate increases, so volume, that is the inversely proportional to the rate. Okay, so volume of the reactor, volume of reactor decreases as rate increases. Rate increases. So means we are getting this much information. What information? As sir, for the irreversible exothermic or endothermic reaction, you have to increase the feed temperature. That is beneficial for us. Increase the feed temperature. So means whatever the feed temperature you are taking, increase that temperature. So, sir, rate will increase. Okay, at the fixed conversion, rate will be increased. Because now you can see, if you are getting this information, and I am hoping that you are getting this. This is the feed temperature now. Feed temperature second one case. Okay, because TF2, that is higher than the feed temperature TF1. You can see fixed conversion XA1. So XA1, what is the temperature, sir? This is the temperature. So exit temperature increases at this conversion XA1. So XA1 is fixed, slope is fixed. So inlet temperature is more, so exit temperature increases. So this is the exit temperature. Rate is in between minus RA4 and minus RA5. So that will decrease from, that will increase from this rate. Are you getting this thing or not? Sir, XA2, in the previous cases when the temperature, feed temperature was TF1, what we get? We get this temperature. Corresponding to this temperature, what is the rate? So you can find out. So rate is minus RA3. In this case, so now you can check conversion XA2. What will be the temperature, sir? Temperature will be this. Temperature increases. Yes, sir. Rate is what? Minus RA5. Minus RA5 is more than minus RA3. Minus RA3. So, sir, rate increases. Volume in this case, when the feed temperature is TF2. Feed temperature is TF2. So, sir, that in feed temperature when it is TF2, it will require the lesser volume. That is the effect of the feed temperature. Are you getting this thing or not? So there is the one term that is called as optimum temperature progression. Optimum. You will tell me what will be the optimum temperature progression. Means inside the reactor. Optimum temperature progression. What path we should follow? What path we should follow inside the reactor? Sir, this path, which type of path we should follow inside the reactor, so that the volume for any reaction, it should be require least. So that is called as optimum temperature progression. Means what will be the temperature inside the, what should be the temperature inside the reactor? Means temperature profile, XA versus T profile, the path, so that the volume will be minimum. So anyone who will tell me for reversible exothermic or irreversible exothermic or endothermic reaction, what should be the path so that the volume should be least? We are getting this information if the feed temperature increases, that is the volume required will be less. My question is, tell me the OTP, now optimum temperature progression, what it will be? Anyone who will try it or will tell me? What it should be? Who will tell me? Optimum temperature progression for irreversible reaction. Either reaction is exothermic or endothermic reaction. Just think and after that give me the answer. Okay, there is no problem if you are giving the right answer or wrong answer, but just try that what should be the best OTP, optimum temperature progression. Pressure slope should be decreased. First of all, tell me the what is the slope of this curve? What is the m? Tell me what is the m of this curve? Because this thing I already told you. What is this m? Just think and give me the answer, na? Otherwise, I will tell you. There is sir maximum possible temperature. Okay, good. Other students? Other students? Sir, you have to think. Anyone who will try to give the answer? Anyone? Sir, will uh, you will make some reply or give me some response? If you are getting it, so okay, sir. If you are not getting it, sir, we are not getting the answer. Okay. So give me the response, na? Only the two students give the reply. So first of all, sir, try to understand this thing, that what I told you already in the last class, means last to last class, that what we are getting the slope, slope that is in this case, okay, xa versus t, xa versus t, the slope that is the, you can say it as that m prime is 1 by m. What it is? So what was the m? You can check. So m is this, means sir, m is delta HR reaction divided by CPI. Fa naught, that is the molar flow rate, divided by summation Fi naught is molar flow rate. So means it will be the minus delta HR reaction divided by CPI. So m prime is what, sir? M prime will be sir, Cp, okay, divided by minus delta HR reaction, means in this way. Understand or not? So CPI or Cp divided by delta HR reaction. This will be the m prime, xa versus t. So the same thing here, xa versus t, same thing here, xa versus t. So that m prime, this is nothing but Cp divided by delta minus delta HR reaction, delta HR reaction. So sir, if I'm able to maintain, if I'm able to maintain the rate as high as possible, the rate as high as possible, okay, minus RA1 minus RA2 minus RA3 minus RA4 minus RA5, okay, minus RA5. So sir, the best path will be, what will the best path? Sir, that the feed temperature, it should be start from the maximum value, and throughout the reactor I will move along this path throughout the reaction, means inside the reactor we will maintain this temperature, that is the T max temperature, that is the best path. I will maintain it as isothermal. My question is that, let's say if exothermic, means irreversible exothermic exo reaction is taking place, then what you have to do takes place. Then what you have to do? Then exothermic means, let's say in starting you make the temperature 500 Kelvin or 600 Kelvin, and exothermic reaction is taking place. So sir, that temperature inside the reactor will increase. What is the best path? That temperature should be the maximum temperature, which is at the inlet. Then in this case, what you will do if exothermic reaction is taking place? Tell me, then what you will do? Then what you will do? Means this is the best path. But how you will maintain this path for the exothermic reaction? This is the question. Why you are not able to give the reply? Exothermic reaction is taking place. Heat will liberate. But this is the best path. How you will maintain this path? This is the question. Tell me. you have to remove the heat. Means it will be non-adiabatic operation. Adiabatic, no transfer of heat in between system and surrounding. In between system and surrounding. So sir, I will do the non-adiabatic operation. If endothermic reaction is taking place, endothermic reaction is taking place, then what you will do? What you will do? Sir, I want that if the heat is required, I will supply the heat. Supply the heat. Heat from surrounding. Remove the heat from system, means that is the reactor. So there will be the interaction of heat in between system and surrounding. Operation will be non-adiabatic operation. But what it will be? Means, but that should be your isothermal operation. Isothermal operation. So isothermal path is the best path. How you will decide the T maximum temperature? Who will tell me? Sir, I want that for irreversible reaction, either exothermic or endothermic, OTP is the, sir, isothermal path. Maximum means, sir, that reaction will be takes place from starting to the exit of the reactor at this temperature, maximum temperature. Sir, for exothermic reaction, how it is possible? Sir, I will remove out the heat. Non-adiabatic operation. If it is heat is required, I will supply the heat. Non-adiabatic operation. There is no problem with non-adiabatic operation. My question is that. What is my question? Okay, that how you will decide the Tmax. How to decide the Tmax? Anyone have this information that how you will decide the Tmax? Sir, any reaction, any irreversible reaction. Sir, if it is taking at the 500 Kelvin, okay, so I will say it has increased the temperature 600 Kelvin. Sir, throughout to the end, yes, 800 Kelvin, 1000 Kelvin, 12,000 Kelvin, because as you will increase the temperature and put the reactor at the isothermal way, reactor operate isothermally, the volume required will be less. Volume required will be less. Will it be or not? But how you will decide that what will be the temperature? What will be that maximum temperature? How you will decide? Means you are not able to give the answer. Okay, because I know all of you very well. So maximum temperature, first thing depend on the material of the reactor. Material of reactor. I will take that temperature which can withstand this higher temperature. So material of the reactor, accordingly I will make the maximum possible temperature. If it can withstand the maximum temperature is 800 Kelvin, so I will operate the reaction at 700 Kelvin or 750 Kelvin isothermally. So material of reactor. Other than that, sir, means I will decide that temperature at which that the operation occurs or the reaction occurs smoothly. According to that, I will decide it. Means operation is easy, ease of operation. Or sir, as per the material of the reactor, okay, accordingly I will decide that what will be my maximum temperature. Other than that, sir, if the catalyst is involved, okay, so catalyst should not decay. All these things I already told you, should not decay at this temperature. At this temperature. So means catalyst should not decay. I will decide that maximum temperature. At that temperature, that catalyst should not decay. Means no poisoning. No poisoning and all these things. No poisoning. Okay. No side reaction occurs. No side reaction happens. I will decide that temperature. No side reaction happens. Catalyst should not deactivate or decay. Deactivate or decay. According to that, I will decide that what should be my maximum temperature. Are you finding all these points or not? Tell me. Now, if the operation is adiabatic, then sir, then what you will do? Adiabatic operation. You already know adiabatic operation means, sir, maximum temperature should be, means I will operate the reaction throughout the reactor at this maximum temperature, but exothermic reaction will takes place. Then sir, exothermic reaction will takes place. Heat will liberate. So sir, if you are saying it as adiabatic operation, so temperature will be rise. I am already taking the feed temperature, means from starting that maximum temperature. So sir, temperature will increase now. At this higher temperature, catalyst material, it cannot withstand this higher temperature. Catalyst may be deactivate, side reaction may occurs. Then what you will do? This is the point. Then what you will do? So Deves is telling if reaction is exothermic, then for the optimum condition, then what we can do, not possible to operate the reactor adiabatically. So sir, try to understand. If it is the Tmax, reaction is exothermic, so what will happen? Temperature will be rise, means will move this side. Okay, so in that case, what is the slope? Slope, that is the m prime is Cp divided by minus delta H reaction. So for exothermic reaction, Cp divided by minus delta H reaction. So minus delta H reaction, what it will be? Positive, so slope will be positive. Will it be or not? Slope will be positive. So slope, that is increased. Slope is increased. But operation is adiabatically. Okay, operation is adiabatic operation. Then what you have to do? What you have to do? If it is the maximum temperature or feed temperature, try to understand. Sir, if heat will liberate, so there is buffering. Other students? So sir, what will happen? Try to understand in this case. Means if we want to operate the reactor non-adiabatic operation, so there is no problem. Then remove out the heat or add up the heat accordingly. But adiabatic operation, so sir, heat will liberate. So what will happen? That heat will liberate. So means just to remove out the excess heat, to remove out the excess heat, what you have to do? Heat will liberate. So just in the feed, you should add up the inert. Add up the inert. Add up the inert. Inert in the feed. Inert in the feed. then what will happens when you will add up the inert? So in this case what will happen, sir? The Cp, the specific heat capacity, so sir, that is the low. When that is the low, so Cp decreases by adding the inert. Cp low, it means slope low, slope will be decreased. uh, Not means, in this case try to understand, uh, by add up the inert, in that case Cp increases, slope that will increased. By add up the inert in the feed, inert will not participate in the reaction, will absorb that heat, okay. So because that at the inlet, try to understand, means as within the feed inert will be added, okay, inert will be added. So sir, that feed is coming at this maximum temperature, but as you will add up the inert, okay, that temperature of inert was low, then heat will liberate, inert will absorb that heat, so in this case temperature will not increased, temperature it will be near about same. So what it will be, that this curve by adding the inert will shift to this direction. Add the inert, so then adiabatic operation, so means heat will liberate, so that what will happen, that heat will be added by the inert or taken by the absorbed by the inert, and after that it will shifted to this vertical line, means again isothermal part, okay. That was the best path. So sir, in this case what I will do, I will add up the inert in the feed. Cp increases, slope increases, then becomes isothermal. So in this way reactor operate at the best path, that is isothermally. Add up the inert in the feed. Devis, are you getting this thing? So isothermal operation, slope that is 90%, slope that is the 90 degree, m that is goes to infinity, tan theta tan 90 goes to infinity, means that the numerator should be high as possible. So as we will add up the inert, so Cp increases, then whatever the heat is liberate, it will absorb that heat, means as we are adding the inert, so means inert Sir, for that inert temperature is low. If it is coming, you are giving the heat, it will absorb the heat, temperature will maintain the isothermally. This is the point. If endothermic reaction is taking place, means reactor operate adiabatically. Remember this thing. Reactor operate adiabatically. Reactor operate adiabatically. So for exothermic reaction, minus delta HR reaction, that is positive. It is positive. Slope is positive. Slope is what? Sir, Cp divided by minus delta HR for reaction. Okay. Slope, that is the positive, means we have to increase the slope. You have to increase the slope. This is the point. Now tell me, for for endothermic reaction, what you have to do? For endothermic reaction, and endothermic reaction is taking place. Reactor operate adiabatically. There is no non-adiabatic operation. Reactor operate adiabatically. Then how you will make it as the best path? Because, sir, for irreversible exothermic or endothermic, the best path is that the reactor operate isothermally. So endothermic reaction is taking place. How you operate the reactor isothermally? When there is the adiabatic operation, means no exchange of the heat in between system and surrounding. Then what you will do? This is the point. Tosif, good. First of all, by adding the inert at the high temperature, then what will happen? Okay, that answer is correct, Tosif. Then what will happen? Tell me regarding to the slope. Good, Tosif. In this case, what we will do, sir? If I am getting that endothermic reaction will takes place, so sir, endothermic reaction, reactor operate adiabatically. So sir, temperature, okay, of the, means temperature inside the reactor will continuously decreased. Will decrease or not? Because for the reaction, heat is required. That heat is taken from the reaction mixture. The heat liberate, or the, so means endothermic reaction, heat will required. That heat will be taken from the the feed is coming, so will decrease the temperature of the reaction mixture. Will decrease or not? Then what you have to do, sir? Add up some inert at the higher temperature. Then inert will not taking participate in the reaction. From that inert, heat will be taken, heat will be absorbed, because that heat is required for the endothermic reaction. Will it be or not? So that heat will be taken from the inerts, and in this way we will maintain the isothermal condition. So what will happen, sir, again? If so that is for exothermic reaction, sir. If endothermic reaction takes place, slope will be negative. Slope that m prime that is greater than 0, m prime that is less than 0 for endothermic reaction. Then what you have to do? You have to increase the slope. So again add up the inert, then you will move toward this isothermal part. Understand or not? Add up the inert. Add up the inert means add up the inert or in the feed at the higher temperature. So just in the reactant to convert into the product, heat will require. That heat will be taken from the inerts. Inert will not participate in the reaction, but they will give the heat for the reaction mixture, and the reactor will operate isothermally. So if reactor operate adiabatically, in this way inside the reactor we can maintain the isothermal condition. This is the point. Understand or not? So you can easily write it, sir. Slope m prime, because in between xa versus t, will be Cp divided by minus delta HR of reaction, minus delta HR of reaction, that will be negative for endothermic reaction. Okay, m prime, so what it will be? It will be negative. So just what we'll do? Add up the inert, in the feed, at max temperature from starting. Okay, maximum feed temperature. Then what will happen? Sir, maximum feed temperature, if it is the endothermic without inert, so temperature will decrease, but with inert, so that heat for the reaction mixture taken from that inerts. So after that what we are getting? So slope will be tends to the vertically. Slope tends to the vertically means slope increases if you will add up the inert. Getting the point or not? Slope increases, moves to the vertically. M is slope is infinite, angle that is the 90°. So in this way we will operate it. Get the point or not? Anyone who have the doubt for the irreversible reactions? For irreversible reactions, either endothermic, exothermic, taking place in the PFR or in the MFR. PFR and MFR operate non-adiabatically. PFR or MFR operate adiabatically. Then what you will do to maintain this best path inside the reactor? Best path is because, sir, if inside the reactor this will be the temperature profile, temperature is constant. So sir, in this case the volume required will be minimum, because you already know the effect of temperature over the feed temperature over the volume. If anyone have the doubt, you can tell me fast. Now, for a reversible reaction,
Hello, hello.